Hi class, in this video we're going to go over some questions in your chapter 17 quiz. So chapter 17 is one of the more difficult concepts in the entire textbook. I would say this is right up there with your elasticity and then also your competitive advantage. So make sure to take this slowly and then absorb all the information, okay? All right, so we talk about oligopoly. Now, before we get started on the questions, make sure you know that what is oligopoly. So oligopoly is whenever you have a few companies, so 2, 3, 4, 5, 6, so not many, so few companies who are in the same marketplace that they're either, they have this interdependence relationship, that the action of one company have impact on the other companies, and then what's going to happen to the market would depends on the level of cooperation between the companies within the market. All right, so we have and then the simplest form of oligopoly is called duopoly. So you know how monopoly is only one company, duopoly is two companies. So this example here will be involving duopoly and also something called a game theory. So make sure you guys go over the informations, know what's a game theory, and I will show you how the individual steps within game theory would develop, and then you can derive your Nash Equilibrium from this game theory and also information. Okay, so the question says, imagine a small town in a remote area where only two residents, Maria and Miguel, owns dairies that produce milk that is safe to drink. Each week, Miguel and Maria work together to decide how many gallons of milk to produce. They bring milk to town and then sell it at whatever price the market will bear. To keep things simple, suppose that Maria and Miguel can produce as much milk as they can without cost, so that the marginal cost is zero. The weekly town demand schedule and the total revenue schedule for milk is shown in the table below. All right, so there's one important piece of information here you guys have to pay attention to, and then every time you see a question like this information will be in the question. So the information is how much is the cost involved. So the cost for this question is very simple. It just says there is no cost, so marginal cost is zero. And the reason why cost information is important because we need this cost information and our price information to determine what is the profit for the company. Because even though for duopoly company, there are more than one company in the market, but the goal is still true as any company in the marketplace is to maximize profit. Okay, so so to do this, so this type of questions here, you're gonna see this. For sure, you'll see this type of question in your quiz, and then the question will be set up different, same way, but they will be asking for different questions. So the first question the system will be asking for, so imagine if this market is behaving in a way such as a perfect competition. So such as perfect competition. What is the market outcome? So what is the price and quantity for the market? So for perfect competition here, we studied this again in previous chapters. The important information for perfect competition you guys have to remember is that your price is equal to the marginal revenue and is equal to the marginal cost. So since our marginal cost is zero, so if your marginal cost is zero under perfect competition, and therefore your price must be zero too. So on this table, where is our price equal to zero, which is the last level here. So quantity of 12, price equal to zero, and this is our perfect competition outcome. So we're going to have a zero price and a quantity of 12 gallons, and this will be shared between your Maria and then your Miguel. And then the other question the system might be asking for, what is the monopoly outcome? Now for monopoly outcome, they're gonna set where the marginal cost equals to marginal revenue, and then your so marginal cost equals to marginal revenue, and then your total profit is maximized, and that quantity is what we're looking for. So to find marginal revenue, you have to find out what is the change in each level of total revenue. So if you sell 1, how much revenue do you have? If you sell 2, how much revenue do you have? And so forth. Now it looks like that our highest level revenue will be 6 units, and if you go above 6, your total revenue actually goes down, right? So you're gonna have a negative marginal revenue. So in this case here, the 12 will be the answer. Don't see that. So 12 is the answer. So this will be the monopoly outcome. Okay, so for monopoly outcome, you're gonna have a price of $12 and then quantity of 6 units. Now again, this quantity of 6 units, this will be shared between Miguel and Maria, so each person produce 3. Now the reason why that's important, because this is the best outcome for the entire marketplace, at least for the 2 sellers. So if you're Maria and Miguel, your best strategy is to behave as a monopoly, and then share the market equally. However, there is a room to cheat, and then this type of system here is always rewarding for cheating. This sounds so bad, right? But it's true. And then this is where oligopoly comes in. That with oligopolies, the companies, even though they're better off to behave as a monopoly together and then share the profit, but there's always an incentive to cheat. So let me show you an example why that is, right? So let me give you a scenario. Let me just zoom in over here. So we said the 2 companies here will share the market equally, half and half. So let's suppose between Miguel and Maria and Miguel, so they both decided, hey, you know what, we're gonna have an agreement that each of us will produce 3 gallons of milk. So the agreement says each person produce 3 gallons, and then price for each gallon is $12, and then each person will have a $36 profit. Now, what if the actual outcome is not like this? Is there something different? Then what if then Miguel decide, you know what, I'm gonna make an agreement with Maria, but I'm gonna have Maria produce only 3 gallons, but I will cheat. I will produce 4 gallons instead. Now, if that's the case, if Miguel secretly produce 1 more gallon, then between 2 of them, they're gonna have a total of 7 gallons of production. Now, according to the law of supply, according to the law of supply and demand, right? So the more of something you have, the lower the price will be, and that is the case on the demand schedule here. So at 6 gallon, the price for the market will be $12, but at 7 gallon, the price for the market will be $10. So price will go down now. So when it go down, then Maria, who didn't cheat, that she can still sell her 3 gallons of milk, but each gallon is only for $10 now. So she will have a total profit of $30. But for Miguel, when he sells 4 gallons, and then he's cheating, by the way, and then each gallon is sell for $10, he will have a total profit of $40, right? So which means Miguel, that he is better off when he's cheating, right? Because he did cheat, he will make a $40 profit. He doesn't cheat, it's only $36 profit. So if you're Miguel, what do? You will cheat. Now, for Maria, it's same information. But you know what, to make it even worse, that for Maria, that because just imagine if you're Maria, and then somewhere in your head you're thinking, there's a chance that Miguel might cheat. But if Miguel cheat, Maria will be worse off. Then she will have only $30 profit. But what if Maria cheat with Miguel as well? So what if Maria expected, let me use different colors. So what if Maria expected that Miguel will produce 4 gallons of milk, and then Maria says, fine, if you cheat, I would cheat as well. So both parties would cheat the system. So both parties cheat the system and both produce 4 gallons of milk, and that's a total of 8 gallons. Now when the quantity go to 8 gallons, the price will be changed. So the new price will be at $8. So let's see what happens, right? So for Maria, 4 gallons produce $8 each. That's a $32 profit. And then for Miguel, 4 gallons produce $8 each. That's also $32 profit. I can't even write an 8. Come on. Alright, so let's look at Maria here, right? So for Maria, if Maria doesn't cheat and Miguel cheat, she is the worst possible scenario. But if Maria cheat as well, along with Miguel, she's not that much worse off. She's a little better off than not cheating at all. So which means that this type of system here, that both parties are actually forced to cheat, right? So which means this little outcome here, then when everybody's cheating, this outcome is called the Nash Equilibrium. So this is where the market end up at. So even though this looks like the worst outcome, but this is the Nash equilibrium. Okay. So this is what it looks like in the number format. You might also see question like this in the matrix format. So let me show you what that looks like. So we're gonna have area here. So we're gonna have Maria, and who's the other person? Miguel. And then each person have a choice: produce 3 gallons of milk or 4 gallons of milk. 3 gallons of milk or 4 gallons of milk. And I'm gonna do a little square thing like this, and this is called a matrix. Okay. So for this matrix payout, if everybody produce 3 gallons, then the profit for each party will be $36. By the way, the first number representing Maria, second number representing Miguel. Okay, and then if Maria produces 4 gallons and Miguel does only 3, then Maria has a profit of 40, and then Miguel is 30. And over here will be reversed. So if Maria does 3, Maria will have 30, Miguel have 40. And last one, if everybody do 4 gallons, then the total will be 32 for each person. All right, so this is how we read the matrix payout. Okay, so imagine Maria knows for sure that Miguel will never cheat. What should Maria do? Now, if Maria doesn't cheat, she'll get 3. She'll get 36. But if Maria cheat, she'll get 40. And 40 is better than 36, right? So which means if Miguel doesn't cheat, then for Maria is better off with cheating. Okay. Now, what if Maria knows for sure that Miguel always cheat? What should Maria do? Maria does 3, she gets 30. Maria does 4, she gets 32. And 32 is better than 30, so she would choose to produce 4 instead of 3. So you see how it doesn't matter what Miguel does, that for Maria she will always choose 4. So this 4 gallons of production is called a dominant strategy. And then for Miguel, there's also same information. Then Miguel also have dominant strategy. So if use different color, there's so many color here. By the way, if anybody here who is colorblind, I'm sorry. Okay. All right. So if Maria does 3, what should Miguel do? Right. So look at the second number here. Right. So if Miguel does 3, he will have 36. Miguel does 4, he'll have 40. So 40 is better. And then if Maria does 4, what should Miguel do? He does 3, he gets 30. He does 4, he gets 32. So 32 again is better. So this 4 quantity for Miguel is also dominant strategy. So we have 2 parties with both dominant strategy overlapping the same area, and this 32, this is called a Nash equilibrium. Okay, so that's the last question the system might be asking. So what is the outcome for oligopoly when I read this Nash equilibrium? That will be this outcome over here. So 8 and then $64 for the entire market and 32 a piece. Okay, all right, so that's how I answer this type of question. Then let me show you one more matrix payout. So this is another quiz question. So we have 2 companies, and they both have a choice either to produce good quality or bad quality. And then this is the payout, so this is how much profit for each company. And then the question will be asking, what is the Nash equilibrium? Now, before we go into details, if you look at the numbers here, what is the best outcome for the entire market, for everybody involved, for both Acme and Pinnacle? So the best outcome might be this over here. So everybody do poor quality, you get 7 each. That might be the best outcome for the entire market. Now, Nash equilibrium more than likely is never the best outcome. Okay, so let's look at what happens. So let's suppose if Pinnacle, this is the Pinnacle decision. If Pinnacle knows for sure that Acme will choose good quality, what should Pinnacle do? If Pinnacle choose good quality, they will have $6 million profit. But if Pinnacle choose poor quality, they have $5 million. So $6 million is better than $5 million, right? So they would choose to do good quality whenever Acme does good quality. But what if Pinnacle knows for sure that Acme will choose poor quality? What should Acme do? Or what should Pinnacle do? So Pinnacle do good, they will have 8. Pinnacle do poor, they will have 7. So what is better? 8 is better, right? So they will do 8. Now notice how this 2 information is overlapping for both good quality. So this is the dominant strategy for Pinnacle. That doesn't matter what Acme does, Pinnacle choose good quality. And then if you reverse it, do the one for Acme, different color. Alright, so if Pinnacle choose good quality, what should Acme do? If Acme choose good, that's a $6 million profit. To choose poor, it's a $5 million profit. 6 is better, right? And then if Pinnacle choose poor quality, what should Acme do? Right? So good is 8, poor is 7, good is better, so 8, going to choose 8. So this is also overlapping on the same line. So this good quality is also Acme's dominant strategy. So they will always choose good quality. Doesn't matter what Pinnacle choose. So both parties have a dominant strategy, and they will always go with dominant strategy. So for this market, the Nash Equilibrium is this sell over here, which looks like the worst outcome possible. Okay, so that's your Nash Equilibrium. Okay, all right. So guys, this is how you answer this type of question. Have any more question? Let me know. Okay, good luck. Bye bye.